Let's talk about stack versus heap memory. I'm going to run this program and then walk through the source code and then walk through an animation of what's happening in memory when this program executes. So let's go ahead and run it first and see what it does. So I'm just going to clear the screen, compile it, GCC-O, and I'll just say stack versus heap.o and stack versus heap.c. Okay, let's compile this and then run it. So very simple. It just has an output. It says main function called, function A called, and function B called. Okay. Now notice that the function B has a capital F. So anyway, you'll see how that happened. So now let's walk through the source code. So this program, let me close that. There we go. I hope everyone can see the code. I think it's big enough. So we first off, we have the main function, but we also have two additional functions, and their prototypes are declared on line 7 and 8. Function A and function B. They take no arguments. They return no values. So when the main function executes, it creates an array called name and initializes it to the string main and then open parenthesis, close parenthesis. And then it prints it out, okay? And then it creates a variable named A equals 1, and then it calls function A. So this is function A. So function A also defines a variable, a char array called name, and initializes it to the name of the function. So function underscore A, open parenthesis, close parenthesis. And then on line 20, it prints out the name of that function. Okay. And then it declares a variable, an integer variable B, and initializes it to 2. I don't do anything with those. I'm just initializing them so we can see the stack frames when we actually look at the animation. And then finally, it calls function B. And function B is defined starting on line 25. And what it does is it dynamically allocates memory on the heap for a char array of 25 characters. So this is size of char using the malloc function, okay, times 25. And if this is successful, if that is not null, then copy the string function B, okay, plus a null character, null terminator, to the name char array. Okay, you could call this a buffer, essentially, right? It's just a buffer with chars of size 25. So as long as we're not overloading that buffer, we should be good to go. And then once that has been initialized, then access the first element of that name and set it to capital F. Okay, so that's what we're doing here on line 29. And then print, and then free that memory. Okay, so now we've allocated that memory, so we have to free that memory when we're done with it. And then this function ends, and then when function B returns, function A ends, and when function A returns, the main function ends and the program exits. So that's how that works. And so once again, if we take a look at the terminal output, we see that main is called, right? The name, that's just printing out the name of the function, saying the name is a main function called, and then function A called, and function B called. Okay, so that's very simple output. So now let's take a look at the animation of this code in the stack and the heap. Okay, here we have the code, When this program is loaded into memory by the computer, it creates a process space with a code section and two areas called the stack and heap. The main method executes, which allocates the array for the string and the integer, and then function A executes, which creates another stack frame. It allocates name and then B2, and then function B executes, which dynamically allocates the memory for the string function in the heap. And then the first letter of that string is changed. And then once function B goes away, it frees up the memory, okay, from the heap. And then function B goes away. And then function A goes away. And then the main exits. And then that the program exits, and that memory is then released by the operating system. So once again, let me run this program so you see the output. Very simple. The animation showed how the stack frames for each of the functions grow downward, beginning at the top of the stack. And then when function B allocates the string dynamically on the heap will grow upwards. I only showed one dynamic allocation, but if you were to dynamically allocate more memory, that heap would be consumed from the bottom of the heap up towards the stack. So the operating system keeps those two memories separate, but you can run out of room. If you don't have enough process space and your program consumes a lot of memory, you could eventually run out of memory, right? So you never want to assume that your memory request was successful. This has been a short video. I think these concepts are important to understand things that you're going to learn later on in the boot camp. I hope it was helpful, and I will see you in the next video.